Hey, and welcome back. In this video, we are simplifying IPv6, what it is, why we need it, and how it actually makes the internet stronger. Let's dive into it. Simply put, IPv6 is the next generation in IP addressing. It's basically a bigger, more powerful version of IPv4, and it was created because we ran out of IPv4 addresses. Where IPv4 uses 32 bits, IPv6 uses 128 bits. This gives us almost unlimited unique addresses that we can assign to all devices. Okay, so think of it like this. Imagine IPv4 as a small city with limited addresses to give out. Over time, every road, street, and house eventually takes all of the addresses. Whereas IPv6 isn't a small city, but rather a completely new continent. One that has what seems like endless roads, neighborhoods, and houses that all have faster and smarter infrastructure. IPv6 doesn't just give us more space, but it gives us a much more robust design. For more in-depth explanation, IPv6 addresses are 128 bits long, like I said before, and they're written in something called hexadecimals and are separated by colons. Now, I do plan on making a full dedicated video all about hexadecimals, but for right now, let's just focus on IPv6 as a whole. Now, IPv6 addresses contain two main parts: network prefixes and interface IDs. Network prefixes identify the network segments, while the interface ID identifies the specific device. Leading zeros can be dropped and groups of zeros can be replaced by colons with a space in between, but this can only be done once per address to simplify writing. But why did we need this anyway? As I talked about earlier, the world actually ran out of IPv4 addresses. There was only about 4.3 billion combinations, and with billions of smartphones, Internet of Things devices, cars, and pretty much everything under the sun wanting to connect to the internet, IPv6 became essential. On top of that, IPv6 doesn't just expand capability, it also improves performance and security. With built-in IPsec for encryption, simplified auto configuration so no need for NAT or manual setups, efficiency in routing and multicast communication, and end-to-end connectivity restored. Now, talking about transitioning from IPv4 to IPv6, both of these things can coexist together through things called dual stacking, tunneling, and translation methods. This ensures compatibility while networks gradually shift to full IPv6 deployment. You'll often see hybrid systems using both until full migration happens globally. To wrap it all up, IPv6 is the future of networking. It's bigger, it's faster, and it's built with the modern connected world in mind. It's not just bigger, but it's also better in terms of its overall design. Understanding IPv6 means that you'll be ready for networks of the future. And that's it for the video. I hope you enjoyed it. If you did, smash that like button, subscribe so that way you don't miss out on further content, and remember, work with what you got and build what you need. And I'll catch you in the next one.